So a recap of last week, we have this table and we want to know which one of these equations, equation 1, 2, 3, or 4, matches our table. And so remember last week we did our finite differences. So we subtracted these and we decided, does that equal the same thing? And so we would check each one of these and see if they're going to be the same each time. And if they're not the same each time, then we go to the second finite differences and then the third. And if they're still not the same, then we look at things called common ratios. So we divide them by each other. So we would do 1/9, 1/3 divided by 1/9, 1 divided by 1/3, 3 divided by 1, 9 divided by 3, and 27 divided by 9. And are we getting the same thing each time? So if you look at these, you can see that every time that we divide, so we do 1/3 divided by 1/9, then that's going to give us 3. 1 divided by 1/3, that's going to give us 3. 3 divided by 1, that's going to give us 3. These are the common ratios. So that says that our exponent is a variable. So that says that our answer has to be f of x is equal to 3 to the x. Okay, on this one it says Vinny collects population data about a specific strain of bacteria over time, as shown in the graph below. So once again, they want to know which graph matches that equation. They give us the data points, and from there we can create our own table. So if we look at the table that these would create, then we have our x and we have our y values. And so we would do 0, 4, that's that first one right there, 1, 8, 2, 16, and 3, 32. And so if we look at those values, then we can see that each one is doubling each time. So every time we go up one, if we were looking backwards, because that's how we do our common ratios, we do 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. So that says that we know that we're looking at one, it has to have a factor of 2, and that our exponent is going to be a variable. So we look at these, and so on number 4, the exponents, the highest exponent is a 3, so that's not a variable. Our highest exponent is a 2, so that's not a variable. And here our highest exponent is 1, and that's not a variable. But if we look at 1, our exponent is our h, so therefore that is the one that would be having the same common ratio of 2. Okay, so we see when we have these um, points that they give us, the data points that they give us, we can use these to form our own table if we wanted to. But on this, what we want to look at is what function is it? Is it a function? And the domain and the range values. So we want to kind of look at these and get an idea of what changes on the domain and the range. So the domain just means whatever our x values are. So domain is the x value, and the range is the y value. So if we go up here and we look at this point 1, -2, well, remember that's the same as this, x, y. The x comes first. So if we look at our domain, then that's going to be all the x values that are listed there. And typically we put our negatives first. So our domain would be -2, -1, and +1. And even though that +1 repeats, we don't have to write it twice. So you just write it one time because those are the values. So the only values that it could be are 1, -2, -1. And that's it. So now we look at our range. So what can our y values be? So our y values can be -2, 0, 2, or 3. And so that's all just from looking up here at this, and we say this is what the first number is in each of those groups of parentheses. That's our x value. And then our range is whatever the second number is. That's the y values in each of those groups. Now, to determine if it is a function or not, we need to look at the x values. Do the x values repeat? So if the x value is there twice, then that is not a function. So here we have a 1, and then here we have a 1. Now, those are not with the same number. If it said 1, -2, and then over here it said 1, -2 again, that would be a function. But since this is 1, -2, and then 1, +3, then that is not a function. It has to be what is called 1 to 1, meaning that for every time that we see the number 1, we know that the only number it could be would be -2. So, like -2, 0, that one's beautiful. -1, 2, that one's beautiful. But the +1 has two different y values that apply to it, so it is not a function. Okay, on this one, I'm going to write it down below because I forgot my stylus, and so this is written kind of bigger than normal. So we want to start off saying like what the relation is. And the relation is just putting those points on there. So our relation would just be the little bracket, and then we would look at putting all of these points into our relation. So this first one right here is -2, -2. And then our next one, going from left to right, would be -1, +1. And then our next is at +1, 0. And then +1, 1. And then +3, -2, and then +3, +3. And we put the little bracket around it. Okay, so we have our points, and that's the relation. So all that's saying is those are the ordered pairs. A relation is any set of ordered pairs. So then we say, okay, what is our domain? So our domain, and for the sake of not having to write it again because I don't have enough space there, I am going to say that my domain is the one that I'm going to do in this light green. So I'm going to underline these values in this light green, and that is my domain. Okay, so then what is my range? So let's pick a different color. So let's just use this red, and we're going to use the red to do the range. So all of the second ones are my range. And then is it a function? So remember, once again, we are wanting to look at the first value, so the ones that are underlined in green, do they repeat? Well, the -2 doesn't repeat, so that one's good. But the -1 is good too. Oh, now look, we get to +1, and we have +1, 0, and +1, 1. And so those repeat, so it's not a function. Okay, these are more of just like those that I just did. This is kind of the same thing. So you're just going to You're just going to list your points, and that's your relation. Then you're going to list all of the x's, that's your domain. You're going to list all the y's, that's your range. And once again, for the function, do the x values repeat? The x values cannot repeat because it must be 1 to 1. So these are exactly the same as the last ones. Let's look at number 12 there. And I'm going to underline again because it's a little harder for me to write these. So we have 1/2. Sorry, that didn't show up. We have 1/2. Oops. 1/2, we have 1/4, we have 1/8, and we have -1/2. Now those are my x values. So that tells me that those are not repeating, so that would be a function. So here we would say yes. And then we look at our y values, so our range. So our range here, this one's really easy. I can write this one. So our range is 2, 2, 2, 2. So our range, and you put those little brackets. Sorry, they're kind of hard to draw that tiny. And so our range would be 2. That's it. Okay, on these, we want to look at where the domain and the range stop. These are continuous because the line continues. But we need to say what is the lowest point and what is the highest point for each one. So looking at number 13, we say what is the highest point? Well, the highest point is right here. And so that one is at 9. So that's the highest that my x value, well, it's at 9. Yeah, I'm sorry, that's the highest that my y value can be. So the highest that my y value is going to be is 9. What is the lowest? So it's right here at -8. Oh, I'm sorry, this one's lower. So -9. So you're going to say that, I'm sorry, I'm going to have to write that down here at the bottom. So you're going to say that -9 is less than or equal to y is less than or equal to 9. And that basically just says that y is anywhere between -9 and 9. So you can't have a value that is anywhere outside of that on this function. And so we look at our x values. So from left to right, what values can it be? So it stops it right here and right here. And so that is at 7 is our largest one. And that's going to be an x. And then our smallest one is going to be at -5. And we put those less than or equal to signs in there. So that just says that x has to be between -5 and +7. And those are the only values that y can be. It's every number between those 2 points. And so on this page, we're going to do the same thing. We would just look at each one of these and say, what numbers can it be? What numbers are restricted? So we look at what is the highest y, what is the lowest y, what is the one to the most left and the most right for the x values. And then we decide, does anything repeat itself? And so when we talk about repeating itself, we have something called the vertical line test. Vertical line. And we abbreviate that by just calling it the VLT. And basically what it says is that if I can draw a vertical line through any point on my graph and it only touches the graph one time, each line, one time, then that is a function. But if I draw it and it touches my graph more than once, then that's not a function.